Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. Okay, so now I'm going to talk about Docker. Now the first question, very first question is what is Docker? By the way, guys, I'm not uh, teaching you through slides because slides typically I use in the corporate sessions when you have a 3 days, 4 days of sessions only for Docker. So that way you run slides for few hours and then demo and then followed by lab. So right now I want in a less span of time, you should get maximum knowledge and without you losing the interest sitting in front of laptop for longer hours. So I will use the notes also, but recordings for the longer sessions, I think I told you where to find it out. Okay, so just give me 2 seconds.
This conference will now be recorded.
Okay, so the next question is what is Docker? So here when I say Docker is a container management tool. Now the question is why we are using tool. All of us know nothing great. Saving cost, save time, and improve the quality of work. This is something which you do that. Anytime you change the tool, there are some advantage. That's the reason we are learning. So now you are learning Docker. Earlier you were doing something else. 100 years before we were doing using some different tools for different work. So like that. So tools we are using for that purpose. But the question context has to be done. This tool for what? Okay, I'll save cost. Okay, how come? Save time. How come? Improve quality. How come? So in order to understand, you have to understand managing what? Container. So this tool will manage container. So when I say manage means what? Yesterday, I mean last session I discussed and told you VMware and VirtualBox manage what? Any idea what they manage? All of you?
Pardon?
VirtualBox manage what?
Virtual machines.
Like container?
Wonderful. No. Virtual machines. Sorry. VirtualBox manage virtual machines. Simple. Correct now? Virtual machines. So here Docker manage what? Container. So when I say manage, that means create a VM, start a VM, stop a VM, restart a VM, pause a VM, uh, unpause a VM, kill the VM, remove the VM. So here on the same context, Docker will create a container, start a container, stop a container, restart a container, pause a container, unpause the container, kill the container, remove the container. That is what I've been telling you. So here Docker manage means Docker create container, Docker start container, Docker stop container, and so on. Why? Why then you will say, Rajesh, why we are using container then? Reason you have it, you want to save cost. So here save cost in terms of earlier, if you remember the DevOps discussion, earlier we were running an application physical server, then virtual server I taught you last session, and now container. So saving cost in terms of what? So one application, let's say you are using 1 GB RAM. Here let's say in virtual machines 1 GB RAM, you have it and you can run 2 virtual servers or 3 virtual servers. Same 1 GB RAM here you have, and you can run 3 containers, 5 containers, something like that. So cost optimizations, so same resources, but you are running only one app. You see here, only one app. Here you are running 2 app in the same price, and here you are running 5 app. Got it? Why? Why we are moving? If someone will ask you why you are migrating to Docker, simple, because container is the most cost efficient in terms of resources. What resources? CPU, RAM, storage, operating system cost. 4 things, remember that. CPU, RAM, storage, operating system cost. Save by container technologies. Now here, how it will save your time? So if you set up, if you remember that, If you set up one application in a physical server, probably it will take 1 day. If you set up the one application in a virtual server, probably it'll take 5 minutes. And here, if you set up one container in a Docker, 1 second. Thousand application you want to set, 1 second, saving time. You want to I'll put it in this way. You want to set up a dev environment. I remember I used to spend whole day for setting up the dev environment. A lot of documents, this that. Nowadays, if you're on containers, one command within a 2 to 3 seconds, your dev environment is ready. Q environment is ready. You want to have an older environment ready. So all this thing is for that only. Got it?
Yes,
Got
Rajesh.
it?
Got it. Yeah.
So now improve quality means what? See guys, your fundamental responsibility, you know what you have? Write a good code and do the proper testing. Fundamental responsibility of any software engineers. But what we do? I'm doing build, I'm doing meeting, I'm doing follow up, I'm sending an email, I'm doing this, I'm doing that, I'm setting up a dev environment, I'm setting up a QA environment, I'm troubleshooting infrastructure. Dev environment is not in sync with the QA is not sync with the production, lots of meeting, war room, this, that, and all kind of things. So if I save all of your time because of this technology, so where you spend? Quality code, quality testing. So improve quality of the software ultimately. So yes, these are the some of the advantage you have it. And what Docker is doing, it managing the container. In if someone will ask you detail, you can say, and what is Docker? Docker is a container management tool. Are you comfortable, all of you? Hello?
Yes, Raj.
Yes.
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 Yes,
So
Raj.
now next questions you may have in your mind, what is container then? What is container? But before that, I'll conclude that guys, Docker is written in Go. Okay. Just avoid the spelling mistake because sometimes I do that while writing the notes. So it's written in Go by Docker, by Solomon Hykes. He's the developer. Okay, who's the founded the Docker. He's the father of Docker container. Now they have a multiple releases actually. In terms of releases, which you see, they have a community release and they have an enterprise release. Whether you go for community and enterprise, both are same. The only thing is community supports are there, no supports. Community supports will be there, and enterprise you have a support from the Docker. So community, the spelling mistake actually, right? Yeah. So enterprise you have support, in community you have no support. Now the version I'm not able to recall actually exactly, maybe 22x. Let me just check this because I keep forgetting so many tools versions and all. So here is a release notes, and for Docker engine, where is that? Here, Docker means Docker engine. Okay, 24 actually. So I think recently they got released. So yeah, 24x. Yeah. So this is the Docker. So now here, when I say next question is what is container, guys? I'll put it in a very simple way. Okay, very simple way. See, VMs you get it from where? Tell me. VMs, how do you create it?
Through images.
Yeah. So VM image. Okay. Someone will call you. How do you get a VM? VM image. And VM image. You have, it's like
Yes.
have a
ISO VH.
the boot file system. That's we call it kernel. Correct now.
Uh,
And plus a root file system. I hope you remember my kernel topic. Do you remember anyone? Boot means kernel. Root means anything start with the root. What you see inside a computer, that is root. And then user file system, and then application file system. So these are the 5 file systems. You see that. Now here, boot is like a kernel. You can download any Linux kernel and then check it out. which is get it loaded in a ROM, if you remember that in a kernel discussion. But root file system I can show you. I think I have shown you last time also. So here, this is a good image. So I'm sure you are knowing about this. Correct now? Correct now?
Yeah, Rajesh.
Yeah. So this is a root file system. User file system, I am in Windows right now. So let me show you my user home. Only this is, I can see this my file system. I have a desktop download, all this blah, blah, blah. It's my system. My users belong to user. Application file system, you go to any application. Typically I install all of my application C drive and C tools, and these are the so many applications. One of this, these are the files and folders for application file system. So if you see that in a VM you have a 4 file system. Some kernel will be there, some root will be there, some user like administrator by default will be there, and some applications like calculator, ls, more, cat, or in Windows if you see notepad or browser, or all this thing will be there. So guys, in a VM, VMs you create from the VM image, and the VM image you have all this thing. Are you clear, all of you?
Yes, Rajesh.
So here in a container, what we have? So guys, container also come from the image, but here we call it a Docker image. Okay, and Docker image had what? That you should ask actually. So Docker image have this part only. That means you may have applications, some users root file system, but no boot. That means in a container you do not have kernel. In a container you do not have kernel. Are you understanding, all of you?
Yeah, Rajesh.
Yes.
Right.
Yes,
So
Rajesh.
then you will say, Rajesh, how come is possible container? How come container can run without a kernel? How that is possible? So actually that's not true. Containers cannot run without a kernel, but there is some optimization has happened, and this optimization has been done by Solomon Hykes. And this I'll put it in a story, not getting in the too much of technical, because you have to unfold the kernel in more detail what I taught you. So that is not, you want to get into that. So what to do? So let's understand in this way. I'll create a few image, you will understand very easy way. So here, what is happening? Let's talk about the typical runtime. So in order to run any application, what happens? So you have a hardware layer. On top of you have a kernel layer. Okay. On top of that, what happens? Few resources you need it. What resources? I must write it. In order to run, in order to run applications, you need what? So first you need a hardware. Then you need kernel, and then you need few things. What things you need? So then you need a namespace. Namespace, what is that? So this user namespace, PID namespace, network namespace, and mount namespace. MNT means root file system. Okay, just to simplify, root file system. Okay, and then you need a CPU and RAM, which is called C groups, and one you need capability. Now you must be thinking what I'm talking about, all this stuff. So guys, the kernel is a program, mind it, and programs create, these are the resources. Okay, so what exactly you have it? These are the resources. So you know what? Very simple way I'm putting up uh, here. This, in order to run any applications, you need one user, one PID. Net, if you want to access the application from outside network also, and where application will be stored in the root file system. So you need 111. CPU and RAM you can get it from here, CPU plus RAM. And capability means this user should be having some access, right? So here this capability will give access to the user. Someone is root, someone is not root. How it will be decided? By their capabilities. C groups allocate the CPU and RAM. Now I want to show you in Windows only because it will be easy for me and to you to also understand. Look at this here. This is the detail table. Look at this, guys. So many applications I'm running in my Windows, and almost same concept we have in Linux also. Okay. So why the PID is not showing? Huh? See here, starting with the 0. So here you have, so whole world, everything, whole universe is starting from nothing, not a thing. So same way your computing environment is also starting with a 0. That means nothing. You see that. So in Linux also you will see something like that. I think I have a one Linux box ready. But where, I think this one, just one session has happened of Ansible. So I use this machine. See that here, 0. Everything, the root of everything in the life or computer, it's nothing. Okay, so here now I was talking about users. So look at this one application, smsss.exe, which is I don't know what kind of application is. It's a maybe system application. Yes, it is. So if you look at it carefully, how do I put it up? So this I want to paste it here. Okay, and then I can pick up a snippet. So look at my screen, all of you, carefully. I know that every day you have spent time here, but this time the context need to be changed. Okay, little bit of it. So guys, this is one application. So like that, you see I have hundreds of application running. And if I say in order to run this application, what you need? So you need a one PID, and see it's running right now. And you need one user. Look at this, user PID. And then you need some CPU, some RAM. Correct? So this is what I was talking about here. If you see that, you need a user, you need a PID. Network means IP address, then which you can access. And MNT means let's say smsss.exe. Where is that file system located? So go to the process properties, and it's located in the file system C, Windows system 32. Let's talk about my application, which is a Google Drive. Let me see that where it's located. So it's located in the C always is a root file system, right? Program files, da da da. So here you need all these resources like a user, PID, network, MNT, and CPU and RAM, which I talked about it here, and then user access. Agree with me, all of you?
Yes, yes.
Okay. So now next question is, okay, you understood this now. So in order to run any applications, you need, again I'm telling you, in order to run any applications, you need one user, one PID, one network, one MNT, some CPU, how to present CPU, some access. Now let me ask you one question. In operating system, how many users you can create? Tell me. How many users? Hello? I'm asking. Hello, I'm audible, right?
Yeah, yeah,
Yes.
Rajesh.
How many users you can create in operating system? N number of it?
Yep.
Yeah, I think so.
Add
How
any
many?
number.
Any number. How many PID tree you can get it? See the PID. This is a PID tree, not a PID. PID tree means what? So PID tree means there is a starting with 0, and then uh, one will be your system. Then one will call you. You logged in. You 2. I logged in 3. This is a user process. Okay. This user run Apache 4. This user run Tomcat in the same machine 5. So this whole things, which we call it a PID tree. So if you see that how many PID tree you have starting with a 0, that means there's not 2 0. That means one PID tree we needed. Okay. So one PID tree we needed here. So here you get only one PID tree, one network. How many C drive you have seen in your Windows? Tell me. MNT means root file system. Simple way I'm asking. How
So,
many C drive you have seen it?
just the one.
One.
Just one, right? So guys, understand that. Very simple concept. You need to understand. Mind it. Kernel is a program. You run programs 10 times, you will get the 10 resources. But operating system is allowing you to create a number of users, but only one PID tree, one network, one mount system. Why? Because operating system guys is saying, hey, I develop operating system for human being, PC, personal computing. Human will do what with for multiple PD, multiple network, multiple mount? What they will do? Nothing. But yeah, multiple users, they are allowing you. Why? You can log in, your brothers can log in, your colleague can log in, with someone is having heavy access, someone is having lesser access. So like that. So they allow that. So see, this is just a program. You run 10 times, you get a 10 users. PD is just a program. You run a 10 times, you get a 10 PD. MNT is just a program. MNT you run 10 times, you get a 10 C drive. Are you understanding conceptually? All of you? Hello?
Yeah, Rajesh, following.
Okay, so now coming back to the topics. So guys, here we have a hardware layer. Okay, understand this is a VMs one I'm explaining, or normal physical server hardware layer, and top of that you have a kernel. Mind it, kernel is here, the one which I taught you last session. And then kernel will create all these resources which just now we discuss. So there's one, I'll change the color. There's one pit tree got created. Remember, only one they create, pit tree, one network, one mount, one root file system. Okay, so this is the mount, this is the network, this is the pit tree. Now multiple users can be allowed. So here one user, Raju, Ramu, Rajesh. Oh, I should change it. Let's say Rajesh, Karan, and Jamie. Okay, so these are the three users we have. Is it possible, right, or not? Possible,
Yes.
right? So guys, Rajesh will access the same C drive. Karan will also access same C drive. Jamie also access the same C drive. Rajesh will have a same IP address. Karan, Jamie. Rajesh also will have a same pit tree and same. So here what we are doing, these resources are common for all three users. Look at this. Now let me ask you one simple question. Okay, simple question. Let's say Rajesh is running Apache, and you know the Apache is running on by default an 80 port. PID will become a 50, and then he is running on the C Apache for the Windows. It can be OPT Apache for Linux. So now let me ask you one thing. Karan also wants to run Apache. Whether he would be able to run it or not. Karan also wants to run Apache.
Yes, Rajesh.
He would be
He
able to run
can.
it.
Yeah, he can.
Are you sure? Think about it, because I know you know the answer. It's just putting in the right perspective. You have to put it up. Mind it. Apache is using 80 port. Karan, this is already consumed because there's only one network, only
Local port
180
is
port.
really on. Yeah.
So this will not be able to run. Again, have you seen
Mm.
this 50 PID ever? You see that this is my system I'm showing you. Look at that. Do you have any duplicate PID here? No, can't be. So Karan can run it if he has to change the port number and the directory. C Apache, he cannot use it because it's already used. Jamie also same way. Karan also same way. That means if I want to run three containers of Apache, I mean three Apache, I cannot run it. I cannot run it. Why? Because kernel create 111. So what to do? What to do to fix this issue in the physical machines? Then people came VMware and all 20 years before, and they say, hey, no, not a problem. You know what? I will create a virtual machine. This means this architecture now will be virtualized. I hope you remember the virtualization architecture. Now here we have hardware. Let me remove this part. So now they say, hey, we have a hardware here. This part. Now I'm converting to virtualization. So here you have hardware. Here you have hypervisor. and on top of that there's one VM, and inside the VM here we have kernel. So if you look at this kernel here also and here also, so here isolation has created. Now this user not needed, not needed, not needed, not needed, per VM per user 80 80 80 80 50 50 50 C Apache C Apache. So that means one VM, two VM, three VM, 100 VMs, and each one of these VMs you can run Apache because these are isolated. That means you have a kernel, and
So
that's called VM world.
means like three users to three VM and everybody
No,
is
not
using.
3 VM, 3 Apache
Yeah.
to 3 VM. That's what I'm saying. Users, anyone in any number of you can create, but it's not useful for in the production, correct? No?
Yes.
So why we created a VM? Just for isolation. Okay, and this hardware you can share to create multiple isolated environment. 1 Apache,
Ju-
2 Apache, 13 Apache, 100 Apache, 100 VMs. Simple.
So like
Correct now?
just yeah, yeah, just little bit like three users, so we can create three virtual machines. No, it's not like that because we want
No,
to
no, no.
use the Apache.
My objective was to run 3 Apache, not 3 user.
Mhm.
But to run any application, you need those resources. You need users, you need paid, you need network, you need MNT, all this stuff.
So Rajesh, you want to say like that if just leave the Apache. If anything other wants to use, so for that they have to create
Wait, wait,
virtual
wait, wait.
machine. Yeah.
I know that what you are thinking.
Hmm.
Don't think this compute you are going to use it. I'm not talking about you, human. I am talking about applications in data
Okay.
center. Application. See, anyways, you are working in the laptop. I am not talking about you. I'm talking about we want to run application at a large scale in data center, thousands of applications. For that, I'm talking about. Got it? Don't think you are going to log in and work on it. No. So, guys, did you understand that why we migrated from physical servers to virtual server? All of you?
Yeah, Rajesh.
Hello? Now,
Yeah,
the
Raj.
problem, guys, what is the problem in this model, which we are using from last 20 years actually? What is the problem in this model? So if you see that, guys, problem, uh, here you have one operating system. Let me change the color. Here you have operating system. Here you have operating system. Here you have operating system. That means, let's say you have more VM. Let's say you want to run 5 Apache, then you need a 6 operating system. That is a problem. Then we'll say, Rajesh, what is the problem here? We ultimately are running, right? But you know what, guys? These 6 operating system also consume CPU, RAM, hard disk, and licensing cost. That is a problem. So if I want to run in data center 1 lakh applications, just imagine if you are 50% of resources also wasting, that means huge, right? Look at the number. Don't think your laptop stuff. Think about the data center. You are running the 50,000 laptop. So that is the problem. So now the problem you have identified, correct? The problem is in the virtual machine is, if you want to run 100 applications, you need to run 100 virtual machines, and each virtual machines you have each virtual machines you have operating system, and each operating system also consumes CPU, RAM, storage, and licensing cost, and that is increasing my running cost in data center. Got it? Got it?
Yeah, Rajesh.
Yes.
So what to do now? So what to do now? So what to do now? So let me create one image and let me propose you one solution, and do let me know if you like this solution or not. So here you have a hardware, here you have operating system, kernel basically, and then let me change the color. Here you have a mount, here you have pit tree, and here you have a network. Now let me move this to little bit down. Now here what I'm saying, this is the kernel. Okay, this is the kernel, and we have discussed, guys, just now, these kernels have these resources, which is nothing but the programs, and we discussed somewhere how many you can create it, correct? So I lost it, that one maybe slides. So you can create as many users and we paid as many network MNT, but OS was not allowing you because you were using for human. So what to do? So here what this guy Solomon Hikes, let me show you his image. Solomon Hikes, Solomon, there's an island actually, Hikes is the one. Okay, this guy, okay, ask this guy, this guy. Okay, so let me put it in this way. Here's this guy, and here he's the one. Here, yep. So this guy asked this guy saying that, hey, can I run one applications in Linux? Okay, can I? So this guy started laughing. Okay, in fact, we should add one more guy actually. Story will be clear actually. So Solomon Hikes asked Linus Torvald and Bill Gates, hey, can I run any application in your operating system? So then this guy started laughing because operating system is built for running application. Don't you think so? So yeah, we can run in Linux, we can run in Windows. That's not a big deal. So let me run one applications. Applications which is here. So here I'm going to run some application, little bit heavy. There's one user created. Okay, and then one applications will be running in a. Oh, by the way, application runs in which space? Anyone remember that? User applications. Hello. Hello.
User space.
Wonderful. And user space, running application in user space, make a call to kernel space using what? I forgot that.
System call.
System call. Wonderful. Yeah, remember that. So here he is asking, can I run application? Yes, of course you can run. What's the big deal actually? Now you know what? Then Solomon asked here, hey, can I access kernel? Can I access kernel? Because kernel typically is accessed by the application running in the user, but controlled access. Okay, so then Linux said, hey, listen, you can access the kernel. I will allow you to access a kernel. Condition number, there's the only one condition: you should not destabilized kernel. So yes, you can do that, and we are open source. We can do that. Bill Gates said, no, 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 you cannot access my kernel. It will become a destabilized. It will be a problem for us. We cannot risk those stuff. Then Solomon Hike said, okay, no problem. I'll stop working for you to develop that application which will support Windows. I will continue working on the Linux. Now you know what? He's installed one applications, and this applications is talking to kernel. and requesting kernel, hey kernel, can you create one what? One mount. He said yes. Hey kernel, can you create one pit tree? Yes. Hey kernel, can you create one network? Yes. Hey kernel, can you create one user? Yes. Hey kernel, can you do one thing? Last thing, can you attach this user to this pit tree, this mount, and this network? Yes. So who's managing this all this thing? Kernel. Who's requesting it? These applications. Now think simple. These guys keep requesting more and more, more and more. Hey kernel, give me create more like this. Now think about it. If this is a user which is running Apache, required 80 port which is coming from here, 50 PID coming from here, and C Apache or OPT Apache coming from here. Same way, 80 port, 50 PID, C Apache, 80 port, 50 PID, C Apache. If you look at the old model where you were not able to run it, why? Because it was the same resources, common resources for all user. But if you look at this architecture here, each user, they have their own resources, and each user they have own resources, each user they have own resources. So now being at this kernel, this you are running 3 Apache, and this all 3 Apache is independent. Now can you please count how many operating systems you have here in this model?
4.
How many?
Just one.
Just
Okay,
one.
okay. Just one.
And in the last model we had a 4 application,
Yeah.
5 operating system. So here what we did, we just changed the architecture of kernel. Okay, Solomon just changed the architecture of kernel, and he's able to create isolated environments where application can run independently without interfering each other. So here, how much time it takes to create? 1 second. That's the reason I'm saying container can be created in 1 second. So here, this all magic is this guy is requesting to kernel, and kernel all the time is not now. It's all the time this was having capability, but no one explored it. Why? Because we develop a compute unit for human, not for data center. Now we are focusing on data center. So now guys here, because the same resources I said in the morning, is the same resources, you are able to run 5 because same resources, you are not running multiple VMs, multiple operating system. So now the question is, what is container and what is a Docker? Any guesses? Who's a container, who's a Docker? Tell me, all of you. So guys, this is the Docker. I've
Container
just
is
now said
nothing but what's the application?
Docker is a management tool. So this is a Docker, and each of these are containers. 1 container, 2 container, 3 container. And that's the reason I said here, look at this. Docker manages container. Docker create, start, stop, restart, pause, and all this thing container. And container is powered by kernel. That means everything is controlled by kernel only in the compute unit. And the only thing is, I'll tell you the difference between you and a container. You are, means let's say all of us are using one machine, all of us are sharing the root file system, network, and pid tree, but these containers are having their own independent network, pid tree, and root file system. That's the difference between you and a container when you log into a compute unit. Got it, all of you?
Okay.
Yes.
So what do we call it? When someone asks you in an interview, detailing, you can do that. Again, I would request you to, spend some time over there and try to understand more better way. But if someone asks you, what is a container? So you should say, hey, container, there's two definition, okay? Container is a lightweight application environment runtime powered by kernel managed by Docker. So here there's lots of things which is there. Now they may find it out, okay, what is a lightweight? What is a lightweight? Lightweight means there is no operating systems over there, no kernel inside a container. Okay, technical, this is the functional definition. Technical definition, container has one user namespace, one network namespace, one PID tree namespace, one this one, what is say last one, user network PID tree, mount namespace, and requested by Docker to kernel, and kernel creates it and attached to it. Got it, all of you?
Have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.